In this class, we are going to discuss about the various design principles. Software design is both a process and a model. The design process is a sequence of steps that enable the designer to describe all aspects of the software to be built. It is important to note, however, that the design process is not simply a cookbook. Creative skill, past experience, a sense of what makes good software, and an overall commitment to quality are critical success factors for competent design. The design model begins by representing the totality of the thing to be built and slowly refines the thing to provide guidance for constructing each detail. The design model is the equivalent of an architect's plan for a house. It begins by representing the totality of the thing to be built, example a three-dimensional rendering of the house, and slowly refines the thing to provide guidance for constructing each detail, example the plumbing layout, the electrical layout. Similarly, the design model that is created for software provides a variety of different views of computer software. The basic design principles enable software engineer to navigate the design process. Davis suggests a set of principles for software design, which have been adapted and extended now in this discussion. The design process should not suffer from tunnel vision. A good designer should consider alternative approaches, judging each based on the requirements of the problem, the resources available to do the job, and the design concepts. The design should be traceable to the analysis model because a single element of the design model often traces to multiple requirements. It is necessary to have a means for tracking how requirements have been satisfied by the design model. The design should not reinvent the wheel. Systems are constructed using a set of design patterns, many of which have likely been encountered before. These patterns should always be chosen as an alternative to reinvention. Time is short and resources are limited. Design time should be invested in representing truly new ideas and integrating those patterns that already exist. The design should minimize the intellectual distance between the software and the problem as it exists in the real world. That is, the structure of the software design should mimic the structure of the problem domain. The design should exhibit uniformity and integration. A design is uniform if it appears that one person developed the entire thing. Rules for style and format should be defined for a design team before design work begins. The design should be structured to degrade gently even when aberrant data, events, or operating conditions are encountered. It should be designed to accommodate unusual circumstances and, if it must terminate processing, do so in a graceful manner. Design is not coding. Coding is not design. Even when detailed procedural designs are created for program components, the level of abstraction of the design model is higher than source code. The only design decisions made at the coding level address the small implementation details that enable the procedural design to be coded. The design should be assessed for quality as it is being created, not after the fact. A variety of design concepts and design measures are available to assist the designer in assessing quality. The design should be reviewed to minimize conceptual or semantic errors. There is sometimes a tendency to focus on minute when the design is reviewed, missing the forest for the trees. A design should lead to components that exhibit independent functional characteristics. A design should lead to interfaces that reduce the complexity of connections between modules and with the external environment. When these design principles are properly applied, the software engineer creates a design that exhibits both external and internal quality factors. External quality factors are those properties of the software that can be readily observed by users. Example, speed of the software, reliability, correctness, usability of the software, etc. Internal quality factors are of importance to software engineers. They lead to a high quality design from the technical perspective. To achieve internal quality factors, the designer must understand basic design concepts. So let us discuss the basic design concepts in the next slide.